Again, we're going to talk about functions and their domains. So one of the things we need to learn about functions for this class is about their domain. So here are a couple things you want to make notes of. When we start talking about finding domains for the functions that we're dealing with, there are two what I'm calling illegals, meaning two illegal things that cannot happen. First, you can't divide by 0, so the denominator can't be 0 of a fraction. And secondly, you can't take the square root or an even root, so 4th power or 6th power, any of those, of a negative number. We're talking about real numbers here. So those are the two things that you have to pay attention to in a function that you're not allowed to do. And therefore, those are two things that affect your domain. When you're asked to find a function, when you're asked to find the domain of a function, I mean, you can use any value of x as long as that value doesn't create an illegal situation. And by illegal situation, I mean those two situations up there. So let's take a look at the first one. Here's the first function, f of x equals 2x minus 1, and we want to find the domain. So does this function invalidate, or is it invalidated by any of the two illegals? And the answer is no. No matter what value you choose for x, you're not going to be dividing by 0, and you're not going to be taking the square root of a negative number. So therefore, there's no illegals, which means your answer is all real numbers. Or if we write it in set notation, which you need to get used to writing in, you would say the domain is from negative infinity up to positive infinity. So it covers all the numbers between negative infinity and positive infinity. Okay, here's another situation. G of x equals x plus 3 divided by x minus 2. Again, remember, you're really only looking for is it disqualify, or is there a problem with the two illegals? And the answer for this one is yes, there is. If you choose x equals 2, the denominator will be 0, which you're not allowed. You can't divide by 0. So therefore, the answer is all real numbers x such that x cannot be 2. Or in set notation, it's going to start at negative infinity, go up to 2, but skip over 2. That's what the 2 parentheses union parentheses 2. That means it's skipping over 2, and then it's continuing on its way to infinity. So everything except for 2, that's the way you write that. And the third situation. All right, so it's illegal if this is 0. Note, there's nothing wrong with the top. The top can be 0. That just means the fraction equals 0. It's only the denominator that we're concerned about. All right, here's another example. This time we have the square root of x minus 4. So this is our second illegal situation. Remember, we're not allowed to take the square root of a negative. We have to be careful what x's we use so that that second illegal doesn't happen. What that means is, what I'm trying to say is, the stuff under the square root must be greater than or equal to 0. So what we do, we say x minus 4, that stuff underneath the square root, must be greater than or equal to 0. And there's your equation, and you can solve that. So we add 4 to both sides, we wind up getting x must be greater than 4, greater than or equal to 4. And that's your domain. The answer is all real numbers x such that x is greater than or equal to 4. Or in set notation, we would say it starts at 4 with a bracket. The bracket means it can be 4. It can actually be 4. And then it continues all the way up to infinity with the parentheses. All right, so to summarize our three little steps here, summary of how to find the domain. First, look for any fractions or square roots that could cause one of the two illegals to happen. If there aren't any, the domain is all real numbers x. If there are fractions, figure out what values would make the bottom equal to 0, and those are the values you can't use. So all real numbers x such that x doesn't equal those values. And then if there's a square root, the stuff under the square root can't be negative. So set the stuff greater than or equal to 0 and then solve it. And the answer would be all real numbers x such that x is greater than or equal to 0, whatever you got when you solve. Note, of course, your variable doesn't have to be x. It can be whatever is in the problem, so don't let that bog you down. So what you can do next, you have 3 examples that you've written down. Now you can do the next 9 problems for homework, and we will talk about them tomorrow. Notice at the bottom I gave you a couple challenge problems to see if you can connect something else into this. So I will see you tomorrow.